And what we've been able to achieve in terms of machine learning has been almost 90% accuracy. And that is significant because if you look at any particular ship, if we try to get the utilization of any particular ship up by even 1%, that is millions of dollars for a single ship.
Good morning, good afternoon, or good evening, wherever you are in the world. This is the Digital Supply Chain Podcast, the #1 podcast focusing on the digitization of supply chain. And I'm your host, Global Vice President at SAP, Tom Raftery. Hi, everyone. Welcome to the Digital Supply Chain Podcast. My name is Tom Raftery with SAP. And with me on the show today, I have Nidhi. Nidhi, would you like to introduce yourself?
Hi, Tom. Really glad to be here. My name is Nidhi. I'm the co-founder and CEO of Portcast. We're based in Singapore, and we're a predictive analytics company working with logistics companies and shippers, and we predict how ocean cargo moves across the world. So we predict the demand and the arrival times of any container vessel around the world using machine learning and various advanced data sets. Really glad to be here.
Thank you. Thank you. Really glad to have you. Before we turned on the recorder here, we had a brief conversation, and you mentioned that you are a startup. You've been in operation for 2 years?
That's right. Yeah. So we're based in Singapore. We're a VC-backed startup. We are a team of data scientists, software developers, and industry professionals who come from the logistics space. But we're working with companies globally. I think technology has made that possible, that we can serve technology from Singapore, but for the world.
Yeah. Technology has made a lot of things possible. We also talked before we turned on the recorder about COVID, and lots of people are now working from home where that wasn't possible before.
Yeah, absolutely.
So tell me, I know very little about logistics, so let's just get that out there. So explain to me like I'm 5. Why would I want to know the departure or arrival times or, of containers?
Yeah. So, interestingly, we don't see shipping as we see trucks, but 90% of the things that you see around you, there's the sofa at the back of you, or the microphone, or the headset, everything's been on a ship at least once in its lifetime. World trade essentially moves on a ship. So shipping is an integral part of getting the goods that we have to ourselves. So what happens in shipping really makes, the costs, the efficiency, and the lead times of how we're getting our goods, really meaningful. And on top of that, it is one of the major components of carbon emissions. So, with the entire climate change conversations, it becomes really important that we start talking about how we can make shipping more efficient, which not only impacts you and I as a consumer, but it also impacts the economy and the environment. Okay.
And how, again, like I'm 5, how does your solution make that possible?
So if you think about logistics, it's a very fragmented market. There are multiple companies who basically come together in order to bring a particular good from China to Spain. There are multiple trucking companies, there are multiple shipping companies, multiple ships. So essentially, it's a very fragmented and disorganized market. All of these handovers mean that there's no single source of information around the end-to-end visibility or traceability of the cargo. And on top of that, there are so many changes that can happen, planned or unplanned. Ships can change the routes, shipping companies can change schedules, but there could be unforeseen events like the port blasts in Beirut, or the US-China trade disputes, or COVID. All of these disruptions make it even harder to get real visibility and predictability, rather, in terms of the supply chain. And that's where we come in. We basically use various data sets and machine learning to enable one single solution where you can see visibility of how your containers are moving, how your cargo is moving, and when it's going to actually arrive.
Okay. But don't ships have, I don't know what the technical term is for them, but like tracking beacons the same way planes have, so you can see where a ship is at any point in time?
Yeah, absolutely. That's one of the data sets that we use. So ships are sort of regulated that they have to send in a satellite information about their latitude, longitude, so their location, what's the next port that they're going to, when are they going to arrive at the next port. However, it's up to the captain of the ship to actually feed that information in terms of when it's actually arriving and what's the final arrival time. They don't have to do it every minute or every hour. It depends on them how often they want to update it. So it's available with a lag or an outdated or static information in that sense. It's not really real time. Secondly, that information is only telling you about the position of the ship right now. It's not really telling you about the movement of the entire ship. So imagine, getting a delivery from Amazon. The GPS of the truck really tells you where that truck is right now. It does not say, and you can, the driver could say when I'm going to likely arrive, but it does not say anything about the traffic congestion that the driver is likely to see, or the roads may be blocked because of construction, or there could be any other disruption that could happen. That's exactly what's happening with that GPS of the ship, essentially.
Okay, so who would be a customer of Portcast typically?
So two kinds of customers. It would be logistics companies, so large freight forwarders who basically manage the goods movement for any manufacturer. And secondly, the manufacturers themselves. So the freight forwarders need this visibility so that they can provide better value-added services to their customers, the manufacturers, and they can tell them exactly where the cargo is, what is going to be at risk, when is it going to arrive, and why is there a risk that we're predicting, and so that they can manage their downstream supply chain better. They can get the trucks just in time. They can communicate to the customer just in time and basically improve their customer retention and service levels. The manufacturer needs this information so that they can get better control of the supply chain for themselves, not just having to rely on the logistics company, but also the cost ultimately is what the manufacturer has to bear. The logistics company does not have to bear the additional port charges if the cargo is delayed and there's no truck available to pick it up and the cargo has to stay at the port. The manufacturer has to bear those charges. So it makes even more sense for the manufacturer to actually get this information in advance. The other thing is that imagine an automotive customer, and if the one single part is not available, the factory line could come to a halt, and that's extreme cost impact for the auto company, rather than just getting that predictive information and early information or notification that there's going to be a delay, and then they can manage that delay much better and make sure that the part is available from some other source. So those are the two kinds of customers that we deal with.
Okay, and the information sources that you use, what typically would they be apart from the beacon on the ship?
So there's definitely that geospatial information, which is the beacon on the ship, or the AIS data that it's called. But also weather disruptions, really granular information in terms of the wind speed, wave height, water currents, cyclones, and so on. The other source of information that we get is directly from the ports, because ports a lot of time have really accurate information about when the ship is actually arriving, when it's departing, when the container is actually getting onto the ship, and so on. We get data directly from shipping companies as well, in terms of how they're planning the ship versus the container, and if they're making any changes to that. And then we get external information about what's going on at the ports. Is there likely congestion? How many ships are waiting at the port at a particular time in the year? So these are kind of multiple data sources. And then the last thing would be economic patterns about what's the kind of capacities at different ports, what are the consumption production patterns in different countries, and what can we see from the economy in terms of how trade is likely to change. And how that impacts shipping.
And you run that all through, you said, machine learning?
Yeah, I think the good thing is that data is all available. All of this data that we're talking about is out there. The hard thing is how we can get this data to speak the same language. How we can secure it in a centralized manner, in a secure manner, keep it updated real time, and then sort of start creating derived data sets on it. So that's really the challenge, and that's the uphill task, which takes some considerable effort in terms of sort of syncing all of this data together. And then it becomes easier to then use machine learning to start making sense of this. And because it's so many different data points that I'm talking about, that's where machine learning can do it better than human intuition. And human intuition is what the logistics industry has primarily been using, apart from spreadsheets and emails and phone calls. So that's where machine learning starts making things a lot more digestible and enables actions.
Okay. What can you speak to successful use cases or success rates or anything like that?
So if you look at baselines of how companies have been predicting demand and arrival times, it's been about 70 to 80% accurate versus the actuals. And what we've been able to achieve in terms of machine learning has been almost 90% accuracy. And that is significant because if you look at any particular ship, if we try to get the utilization of any particular ship up by even 1%, that is millions of dollars for a single ship. If we try to predict the arrival time with high accuracy 5 days ahead, the manufacturer has so much more time to plan their supply chain better. And that saves them, any additional port charges, that saves them time, that saves them buffer safety stock, and it saves them expediting air freight. So it becomes really valuable, even getting single percentage improvements. And I think what we've been able to see is tremendous improvement in the accuracy levels.
How has COVID impacted the logistics industry?
So I think COVID, I only see it as a positive impact in the longer run. I think COVID has kind of increased the urgency for logistics to adopt technology and to digitize much faster. We've seen during COVID how important logistics is. Until now, it was more seen as a cost factor in companies. And with COVID, we've realized that the most important thing is how we're going to get those goods to our home, because we're not going out there and getting those goods. It's our daily goods, which, from a daily goods to anything, fancier beyond that. And that's not just at a consumer level. Every single manufacturer is experiencing that. It all comes down to supply chains being a strategic enabler for getting that competitive advantage. And I think there has been no other time when the statement has made as much practical sense as today. And so when logistics starts becoming important, companies know that they need to then reduce their margin pressures. So they need to reduce the inefficiencies. They need to make it more technology savvy so that any lead times that are lost, any leakages in the supply chain are getting rid of. And that's where I think we've seen a lot more interest from companies during the last few months. And I think we're kind of at an inflection point. So the next 2 to 5 years will see large scale tech adoption in the logistics industry.
Not before time.
Sorry?
Not before time.
Yeah, absolutely. So I think it's really exciting for the industry at the moment.
And have you seen any impacts directly on shipping lines of COVID? Any delays, impacts on manufacturers, anything like that?
Yeah, absolutely. I mean, just today I was talking about a few examples of what our technology was able to see. So, there was a recent cyclone near the Panama Canal. Okay. And we saw ships that were taking a detour because of that cyclone. The shipping company was saying exactly that the ship is actually going to be on schedule and it's going to come at the time that they had promised. But we knew that the ship is actually not going to be on time. It's going to be delayed by at least a day, at least 24 hours, just to the next port. And then there's a knock-on effect to all the ports beyond that. And that's really what we're able to say. And imagine the three ports down that voyage, that information, if they're getting it much in advance, they can really adapt their supply chain to that. So that was one example. The other example is the recent port blasts in Beirut. Mm-hmm. We saw ships that were going to go to Beirut on the day of the blast, and they obviously, for obvious reasons, they cancelled that arrival, and they skipped that port and went directly to the next port. We saw ships that had arrived on the day of the blast and were supposed to leave the next day, And we had predicted that it's at least going to stay at the port for 3 days because of all the congestion that we were seeing around the port. And eventually the ship actually stayed 4 days. So we were really accurate, and we were able to predict that much in advance, so that the not just the shipping companies, but the logistics companies and the shippers can get that information. So I think what we're talking about becomes really tangible with these kind of examples.
Let's change tack for a second, because I mean, this whole industry is very niche, I gotta think. I know, as I said at the start, very little about it. And you don't, well, let's say I go on to Amazon and I order a phone, or I order a piece for my computer or whatever, and it arrives the next day. But you mentioned at the start that everything around me has been in a ship at some stage. So ships coming from China to Europe probably take maybe 3-4 weeks. I don't know, depending, to your point earlier, on how many stops they make en route. Yeah. So how does all that work? That I order something from Amazon and it arrives the next day. Has it come from typically China on a ship, taken 30 days, and then stored in a warehouse? Or is that, it must be something like that, I'm guessing.
Yeah, absolutely. You're right there. So basically, there would have been a factory in China, which is an OEM. Let's say, based in China, the goods would have been filled in the factory in a container. The container goes on road to the nearest port in China, let's say Shanghai, and then from Shanghai it needs to reach Spain. So it takes about 2 to 3 weeks, about 20 days to get to Spain. And then at the port in Spain, the nearest port to your hometown, it then needs to get onto a truck or maybe a rail, and then it needs to get delivered to a particular warehouse of Amazon. So wherever the warehouse of Amazon is in Spain, it gets there, it gets stored there, and Amazon plans the inventory, forecasts the demand, when you're more likely to buy the phone. It forecasts based on that. And it sort of brings in the shipments from China based on those forecasts. So it stocks them in the warehouse in Spain. And when you order, it just needs to deliver with, in a parcel to your home. And that's what it can do in a day's time. But what Amazon has to do on their side is plan that inventory. So they have to forecast that demand based on the consumption patterns they're seeing. They have to plan in advance how long it's going to take for the lead time between China and Spain in terms of the ships that are available, any disruptions that might happen. And then they have to place that order much in advance before that with the factory in China, because it needs to get from the factory to the port in China as well. So all of that is happening behind the scene. And, imagine if Amazon does this all well, and yet there is a cyclone and the ship doesn't arrive on time and it misses that window. You may not get that phone in time. And then you're not very happy with Amazon. So those are the things that are happening behind the scene. Yeah.
Okay. You're a 2-year-old company. What made you get into this? Because like I said earlier, it's a very niche topic.
Yeah, I know. So my background has been in logistics. I worked for Deutsche Post DHL for a decade in Singapore, but my roles were all across Asia Pacific. I did management consulting, business development, and strategy for them. So I was always dealing with customers and issues of C-level executives and customers in terms of pain points that they have with supply chain. And it always came down to inefficiencies and loss of costs. And we were using Excel sheets. We were using emails. We were following up manually. It was not very digitized. And that was the time when Amazon was really gaining importance, because we were talking about Amazon. And we saw, if you just look at warehousing, we saw Amazon almost overnight, they had robots throughout their warehouses. And large logistics companies take time to experiment. They have to roll that out in one warehouse, and before they can make it a global phenomena, they have to really think about the pros and cons and the business opportunities and viability of it before it becomes something scalable. So there is a ramp-up time that is much more significant in a large traditional company versus a new tech provider. But there is real advantage, which is really visible in terms of how technology impacts efficiency, costs, time, and eventually customer satisfaction. And therefore, I was really sort of excited by the role that technology and digitization plays in this space. And shipping was what happened because, like I said, there is a lot of inefficiency in the space, which I see as an opportunity to improve. But eventually, the idea is that what we're doing has a role to play in the entire supply chain, and we could expand throughout the supply chain eventually.
Okay, superb. We're coming up on the 20-minute mark now, which is typically when I start to wrap up the podcast. Is there any question I've not asked that you wish I had asked, or is there any topic that we've not mentioned that you think it's important for people to be aware of?
I think it might be surprising for people if this is, so important. Why are companies not doing this already? So, shipping and logistics has been quite an opaque industry. If you think about passenger airlines, when you buy an airline ticket, it's almost an instant process. You can get multiple options, you can book a ticket, you can get the price dynamically, and you know exactly when the flight is going to arrive or if there's a delay in its taking off. And it's all in minutes. This is not where the passenger airline industry was 2 decades back. It was still agencies where you had to book tickets. It was still pretty manual. But in the last 2 decades, they've very strongly changed how the industry behaves, and they've kind of improved the efficiency and made everything digital. And that's what we think of as normal now. Shipping is still at that 2 decades old space. And, not just shipping, the entire logistics space, but we're seeing the last mile, like with Amazon and with trucking, we're seeing that change coming. The upstream, like air freight and ocean freight, still has a way to go. They're talking about this. They want to make that change, but that's still not at the stage where it should have been. So I think there's real value in making that. It's a lot to do with change management, but the industry has been talking about it for far too long. And I hope that COVID kind of makes that urgency really, really, stronger.
Okay, superb. Nidhi, that's been really fascinating. If people want to know more about Nidhi or about Portcast or about shipping in general, where would you have me direct them?
I'd be most happy to connect with them on LinkedIn, or they can reach out on our website. It's called portcast.io, portcast.io, or they can reach out to me at nidhi@portcast.io.
Fantastic. Nidhi, that's been great. Thanks a million for coming on the show.
Thank you, Tom.
Okay, we've come to the end of the show. Thanks everyone for listening. If you'd like to know more about digital supply chains, head on over to sap.com/digital supply chain or simply drop me an email to tom.raftery@sap.com. If you like the show, please don't forget to subscribe to it in your podcast application of choice to get new episodes as soon as they're published. Also, please don't forget to rate and review the podcast. It really does help new people to find the show. Thanks. Catch you all next time.